Okay, just as a quick recap video, and I suppose a video to use if you ever want to study. I suppose you should be studying, so go back and study trigonometry if you want to do that. And you'll go through sine, cos and tan ratios again, and opposite, adjacent and hypotenuse. Okay, so the trigonometric ratios can only be used in right angled triangles. Okay, so a right angled triangle is a triangle like so. Okay, that contains a right angle. Okay, so the first thing to start off with, right, if we take a right angle triangle, I'm going to draw one out here to correct itself. Okay, and that's the right angle there. Okay, we first look at the right angle and we can label a side based on a right angle. But if a right angle there is there, then our hypotenuse is directly opposite. Okay, hypotenuse is directly opposite. Okay, and the question might say find angle A. Okay, so the first thing we do always is label the hypotenuse. The next thing we do is label the opposite. Okay, and the opposite side is always opposite to the angle you're looking for. Okay, so we're looking for angle A, so the opposite side is going to be here, and that's called your opposite. And if you think, okay, which side is closest to my angle, okay, or the side left over is what sometimes I say as well, because it's often easy to get confused by adjacent and hypotenuse. Okay, but if you label hypotenuse first, then opposite, the sign you haven't labelled is called the adjacent. Okay, and I have written here shorthand, so you don't have to keep writing out the full word every time. That's what I would write for all them. Okay, so I know we've done these parts in class already. Okay, so we've labelled all these, and I was quite happy with your work there. Okay, so the next thing I want to do, I suppose, is go through the ratios themselves. So we have three ratios: one sine, one cos, and one tangent, or sine, cosine, and tangent. Okay, so as I said, you use each ratio depending on what the question gives you. Okay, so if a question like so, okay, so I'll draw a diagram for you here. Question like so. Okay, and it asks you to find angle A. Okay, and you have the hypotenuse. Okay, and you have the opposite side. Well, and you look back, so you go, okay, well, I have hypotenuse. Okay, so label the sides first. That's hypotenuse because it's directly opposite your right angle. This is opposite because it's directly opposite your angle that you're looking for. And this is adjacent because it's left over. Okay, we don't have adjacent, we have opposite and hypotenuse. So what I suggest you do is you go back to where you've written this first, okay, because this is going to take a while to get used to it. You go back to written this first and you say, okay, well, I'd first of all eliminate the ones you can't use. Okay, and you do that by saying, okay, well, adjacent isn't in this triangle, so I can't use a ratio that has adjacent in it. Go back up here. Well, I can't use cosine because it has adjacent over hypotenuse, and I can't use tan because it's opposite over adjacent. So it must be sine. We have opposite and hypotenuse, so yes, it's sine. Okay, so you go sine of A, so sine of the angle is equal to opposite over hypotenuse. How I remember that would be silly old Harry, so silly old Harry. Okay, so sine of A, you fill in your values for opposite. Okay, opposite over hypotenuse. Okay, and you will then get out a value for your angle. Okay, so you could say sine a of a half if you want to simplify it. Okay. And then you can say, right, I want to get a on its own. So you have to do something to both sides in order to get a on its own. So what you do is you invert your trig function. So the a is equal to sine inverse of a half. Okay. So a is equal to 30 degrees. Okay. I went through loads of tutorials in class about how to type that into calculator. Okay, but I'm going to talk through it now. You hit shift, hit sine, and that would make sine inverse. Okay. You then hit your fraction button, press 1 for the one on top, arrow down, 2, across, close your bracket, 30 degrees. Okay. So that's sine. Your next one would be cosine. So I'm going to draw another triangle to represent cosine. So remember, a right angle triangle can be in any orientation, and what I mean by that is it can be drawn in any way. Okay, so as long as there's a right angle in it, it's a right angle triangle. Okay, and this time we're looking for, we'll say C. Okay, so let me see. Okay, so again we label all our angles. First thing we do, so opposite the 90 degree angle is hypotenuse, opposite your angle is opposite, and adjacent is the other one. Okay, so we don't have hypotenuse, so we can't. We'll go back up here again, look at our ratios. Okay, sorry, apologies, this is tangent. Sorry, this is tangent. So I will move this over here. Yeah, so this is tangent. Let's go back up. You say, okay, well, we can't use sine because it's opposite of hypotenuse, and we can't use cos or cos because it's adjacent over hypotenuse. So it must be tan, opposite over adjacent. Okay, so tan of C is equal to, so trawling off America, trawling off America. Okay, fill in your values. Well, tan of C is equal to 36 over 24. Tan of C is equal to 3 over 2. Again, you have to invert your trig function. Again, shift tan your fraction sign, 36 over 24, or 3 over 2 if you simplified it. Okay, close your bracket and you will get 56.30993247. C, I'd round to 2 decimal places, 6.31 degrees. Okay, so that's tangent, and I go through cosine now. So again, if we draw a triangle, it can be any orientation, so I'm going to draw it like this. Okay, so we have, that's a right angle there. Draw it in red to make it more explicit. Okay, again, opposite our right angle is our hypotenuse. Then we have, so we're looking for angle D. Opposite angle D is called your opposite, and the other is called your adjacent. Okay, so we have, okay, 42 and 12. So go back up. We have adjacent and hypotenuse. We don't have opposite. So I'll go look, I say, okay, can't be sine because that's opposite in that. It can't be tangent because it's opposite in that. So it must be cos. Cos. Okay, so cos of D is equal to, so silly old Harry caught a herring adjacent over hypotenuse. Caught a herring. Okay. So cos of D is equal to 12 over 42. Okay. Cos of D is 2 over 7. You invert. D is equal to the inverse of 2 over 7. D is equal to 73.3984504. Round to decimal places, we'll say D is equal to 73.4 degrees. Okay, so that's sine, cos and tan, and using your sides to find an angle.